Okay, so I'm going to go ahead and take a look at the 3-3 assignment, Algebra Properties and Proofs. Number 1 to 10 says justify the following with a property, postulate, or definition. So here are the statements, and then here are the reasons. I highly encourage you to look at your pink sheets, if you still have them, to answer all these questions here. But I can go over a few examples. So let's take a look at the statement. Number 1, if x minus 3 is equal to 9, then x is equal to 12. So it's basically saying, okay, this is my hypothesis, this is the conclusion. So this is the cause, what's the effect? The effect would be x is equal to 12. So I'm adding 3 on both sides, just like a regular algebra problem, right? So then going to my pink sheets, I'm going to go find the page that deals with algebra. And it looks like this one. So if a is equal to b, then a plus c is equal to b plus c. So that plus c, or plus 3 on both sides here, that's me using the addition property of equality. So I just write addition property of equality, or you can say POE for short. Okay, number 2, if 2 times the measure angle 1 is equal to 100, then measure angle 1 is equal to 50. So this is basically like measure angle 1, you can treat that as a variable, okay? It's like saying 2x is equal to 100, and if I were to solve for x here, I get x is equal to 50, okay? So this is my if, and this is my then, right? And this process here was me dividing, right? That's the division property. So in this case, if I were to solve it like a regular algebra problem, dividing both sides by 2, so I get the measure angle 1 is equal to, well, 100 over 2, or 100 divided by 2 is 50. So that process here, specifically this process, that's the division property of equality. Okay? All right. You should be able to do these problems here. Just take a look at the notes and also the pink sheet properties, and then you should be able to get them. Okay. So number 11 to 14, this is where you fill in the statement for each of them. So if I were to say, let's do this one, because I think this is really, really important to understand what's going on here. And you're going to be dealing with a lot of these in the future. So number 13. So here are the statements. Here are the reasons. I'm just going to fill in the blank. So number 1, M is the midpoint of segment XC. And this is my given. What I like to do is, if I have a given and I don't have a picture, I'm going to draw it. So here's X and Z, and then M is the midpoint between those 2 points. So if M is the midpoint, what does midpoint mean? Well, what does the midpoint do to the segment XZ? Well, it's going to split the segment into 2 congruent parts, where I'm going to draw tick marks to show that they are congruent. So segment XM is congruent to segment X. Or sorry, not X. Segment XM is congruent to segment MZ. So that's what I'm going to write. That's the result of that. So it's going to go from here to here. So segment XM is congruent to segment MZ by what definition? The definition of midpoint. Okay. Let's go ahead and take a look at number 14. I don't know why this line is here. We don't really need that, but we can see that my given is angle POQ is a straight angle, and R is not any point on line PQ. Okay, so I'm going to draw my straight angle, which is POQ. And R is any point not on line PQ. So that means I need to draw it outside of this line / angle. So then it's going to create a ray there. And we call that R. So if this is a straight angle, Okay, if this is a straight angle and here's r, which will create a ray here, well, first of all, I want to take a look at this picture and say, okay, if it's a straight angle, how many degrees is this? Well, that's going to be 180, right? So this is going to be 180 degrees. So first, I want to ask myself, okay, what plus what is going to give me 180? Well, we can see that, okay, the measure angle POR, plus the measure angle ROQ is equal to 180 degrees, right? It's basically my part plus part is equal to a whole. So I can write measure angle POR plus the measure angle ROQ, and that's 180 degrees, and we'll say that this is the angle addition postulate, because it's really part plus part is equal to a whole. Okay, so that's the answer. And over here, this should be pretty straightforward. All you're doing right now is you're taking a look at each step and you're going to justify. Okay, so here are the statements, and then you're going to provide reasons for all of these. Okay, so the first one should be a given. That's really easy. So I write given. And then if I were to look at number 15, okay, so how do I go from here to here? Well, I'm going to subtract both sides by 3, right? So this is the subtraction property of equality, and then I'm going to divide as I'm going to the last step, so that's the division property of equality. Okay, so that's how you do, or that's the procedure for these problems here. All right. Now, I'm thinking about going over 18 and 19 because these are a little tricky and it requires you to use your brain. So let's take a look at number 18. My goal here is to prove, this is a geometry proof with some algebra. So it says that given that M is the midpoint of segment AB, and AM is 3x minus 1, and MB is equal to 11. Prove that x is equal to 4. Okay, so I'm going to go ahead and I'm not going to go, this is how I like to do my proofs. I'm not going to look at the proofs. I'm not going to look at the reasons. I'm not going to look at the statements. I'm going to draw my picture and figure out my game plan from there. So given that M is the midpoint to segment AB and AM is 3x minus 1 and MB is equal to 11, these are the things that I can use or I can assume. Okay, I can assume all of this. So I'm going to draw the picture. So here is AB. So I have segment AB and M is the midpoint. So what the heck is going on here? If M is the midpoint of segment AB, what is the result? Well, it's going to split the segment into two congruent parts. Okay? It's going to split the segment into two congruent parts. Therefore, that AM is congruent to, or segment AM is congruent to segment MB. Okay? And this is by definition of midpoint. That's the result of that. When you have that midpoint introduced, it's going to split the segment into two congruent parts. Therefore, segment AM is congruent to segment MB. And I'm writing notes right here because that's going to help me for my proof. Now, I noticed that this is in the language of geometry, and I'm given these things right here. Measure AM is 3x minus 1 and measure MB is equal to 11. This here is in the language of algebra. And over here, this is in the language of geometry. Okay? And then once I'm going from the language of geometry to the language of algebra, I am going to substitute at one point and then proceed from there. Okay, so let's go ahead and take a look at the proofs now, because I think I have an idea on how I'm going to go through this proof. So statements, reasons. 1, m is the midpoint to segment AB, am is 3x minus 1, and mb is equal to 11. That's the given, right? This is basically free, because that's my given, because I know what that is and I can assume. So that's my given. Number 1, given. Okay, then it says, okay, number 2, segment AM is congruent to segment MB. And why? Well, we know that M is the midpoint of segment AB. So that means that this is, by definition, of midpoint. Okay, I don't want you, I know I said language of geometry and that implies definition of congruence, but you're not there yet. Why? So if M is the midpoint to segment AB, what is the result of that? Well, segment AM is congruent to segment MB by the definition of midpoint, and we've already discussed that right at the beginning. Okay, and then this is where, if you are wondering, this is where you're going from the language of geometry to the language of algebra, right? Notice that the segment AM congruent to segment MB, I'm using that language of geometry, and this is a dead giveaway. And I'm going from here to here. Notice that the segment bar is gone for each, and I'm using the equal sign. So that means, and that implies that I'm using the definition of congruence. That's the whole language stuff, okay? Definition of congruence, okay? Now, I'm going from AM to 3x minus 1 and MB to 11, okay? Yes, I know that's all given, but right now, this here is my setup phase. This is my setup phase. So I'm trying to set up my equation, in order for me to do the algebra steps. Okay? So now I know that AM is, or not now, but I already knew that AM is 3x minus 1 by the given. And then MB is 11, also from the given. This is me basically substitute. I'm replacing these variables with the expressions here. So that's going to be my, this is me using the substitution property. Okay? And then going from here to here, this is just algebra, right? So here, this is my given. Here, this is my setup phase, and then now I'm going to the algebra phase. So I'm going to add 1 on both sides. That's the addition property of equality. And then I divide both sides by 3, so I get x is equal to 4. So that's the division property of equality. Okay? So that's how I like to do these proofs. So I look at my given, and I'm not going to look at this at all, okay? I look at my given, I draw my picture, I use the definitions or properties or theorems that I see from the result of that given. See that how M is the midpoint? Okay, what does the midpoint mean? Well, it's to split the segment into 2 congruent parts. What's the result of that? Well, if M is the midpoint of segment AB, then segment AM is congruent to segment MB by the definition of midpoint. And I can see that this is also given, so that means I'm going to start setting things up where I'm going to go from the language of geometry to the language of algebra, and then replace substitution property, and then we got to this part, which we are just doing regular algebra, okay? Hopefully that makes sense. Over here, I'm going to take a look at number 19. It says, given that V is the midpoint to segment SW and W is the midpoint to segment VT, prove that segment SV is congruent to segment WT. Okay? You cannot assume the prove, right? That is your goal. You are trying to get to the last step. So you cannot just use this at all until you get here, if that makes sense. But like I said, I'm not going to look at all this. Well, I just did, but I don't want to look at that. I'm not looking at it. Number 19, look at this, draw your picture. So we know that V is the midpoint of segment SW, okay? So I'm going to draw this. So here's SW, and V is the midpoint. So if V is the midpoint, y'all, what is the result of that? Well, it's going to split the segment into two congruent parts again. So that and that are congruent. So I'm going to write that down. Segment SV is congruent to segment VW. And this is by definition of midpoint once again. And then we can see that W is the midpoint of V. And then where's T? We're going to have to draw T. Here's T. Okay. So then if W is the midpoint of VT, what's the result of that? Well, again, it's going to split the segment into two congruent parts. Okay, so that means I have to draw another tick mark there. Okay, so let me do that, and then we can okay, there you go. And I don't really need this anymore. Okay, so what was the result of that? Well, we said that W is the midpoint to segment VT. So by definition, VT or segment VT is congruent. Oh, no, sorry. If we know that W is the midpoint of VT, then we can see that segment VT is congruent to segment WT. So segment VW is congruent to segment WT by definition of midpoint. So that's going to be very, very helpful. Okay? Statements. Reasons. Number one will always be given. That's free. But the fact that this is already stated here and nothing is written here, that means I'm going to have to write the whole given. So I have to write all of this. So V is the midpoint of segment SW, and W is the midpoint of segment VT. So that's a given. Okay. Statement 2 says segment SV is congruent to segment VW. And what's the reason here? We said it was by definition of midpoint. So definition of midpoint. Okay. And then here's 3, and this also says definition of midpoint. And this is what I wrote here. So segment VW is congruent to segment WT by definition of midpoint. And then lastly, the prove should be right here. So segment SV is congruent by segment WT. But why? Well, let me go back to the pink sheets. And I'm going to show you this. It's called the transitive property, which they said if A is equal to B and B is equal to C, then A is equal to C. Or, specifically this one, if segment DE is congruent to segment FG and segment FG is congruent to segment JK, then segment DE is congruent to segment JK. So I don't need this anymore. Segment DE is congruent to segment JK, right? So if I go back, well, segment SV is congruent to segment VW, and segment VW is congruent to segment VT. Whew. Look at that. Segment SV is congruent to segment WT by the transitive property.